Hello, my name is Bhavin Shah and I'm a Senior Technical Marketing Manager with Portworx by Pure Storage. In this video, what we are going to talk about is how organizations can run virtual machines and containers side by side on a Red Hat OpenShift cluster that has Portworx and OpenShift Virtualization installed, but how they can still use Portworx to provide data protection and disaster recovery solutions for their VMs and containers running side by side. So for this demo, what we have done is we have a primary OpenShift cluster. As we said, we have already installed Portworx and enabled OpenShift virtualization as a feature. Now, if I want to deploy an app in this namespace, I can start deploying a virtual machine object, a OpenShift or a Kubernetes pod object, service objects for both of those components, and then I can have persistent volume claims for my VM and as well as my pod. These PVC objects correspond to or are deployed by Portworx storage classes. So if you're running this on bare metal nodes on-prem inside your own data center, or if you're running this on AWS as a managed service called Red Hat OpenShift service on AWS or ROSA, these can be running locally on the nodes itself. So let's say I have a 3-node OpenShift virtualization cluster where I'm running this application. So both of these PVC objects can have the same storage class, or they can have different storage class, which means they can have different levels of replication and QoS policies. Let's say my virtual machine object is running my database for my application. So I want it to be highly really resilient to any failure. So I'll make it replica factor of 3. So it will have 3 replicas, so a primary and then 2 more that are spread across different PVC objects. For my front-end container or my front-end of component of the application, maybe I only do like 1 additional replica. And this protects me from any kind of node failures or availability failures. But that's basic, right? That's not what we want to talk about in this video. We spoke about it in a different video at length. In this video, what we want to talk about how organizations can build data protection and disaster recovery solutions, both async and synchronous, using Portworx. So let's start with the synchronous disaster recovery solution, right? Let's say I'm running this in an AWS region, and I want to make sure that I'm protected against any cluster failures, AZ failures, just failures in general, right? And I still get an RPO of 0, or a recovery point objective of 0, which means I'd never lose any data for my application. Portworx can help you build this DR or synchronous DR solution by using PXDR in a synchronous mode. So in this case, what I'll have is a primary cluster and a secondary cluster, both running in the same AWS region, or if you're running this locally in data centers or in physical locations that can meet the less than 10 millisecond latency, round trip latency between the 2 sites. Once I'm able to meet that, I can basically stretch my Portworx cluster across my primary and secondary cluster. So any write that comes in to any of these persistent volume objects automatically gets copied on the secondary side. So I'll have replicas for those persistent volume claims ready to go on the secondary side. And in case anything happens to my primary site, I can basically bring my application that was running in the namespace back online in a matter of minutes, instead of having to provision new clusters, finding out the latest snapshot that I want to recover my application from. This is that true disaster recovery solution with a recovery point objective of 0. But now let's say I want to build a more cross-region or a cross-cloud architecture. Maybe I want to build that hybrid cloud architecture where my primary cluster is running on-prem, but I want to use that ROSA service as that insurance policy running in the cloud as my tertiary site. So if anything happens to my on-prem data center, I can still recover everything in my cloud location. In that case, we'll build an asynchronous DR solution using Portworx. So in this case, I'll have 2 different Portworx installations. So I have Portworx running on my tertiary cluster, and I have Portworx already running on my primary cluster. And at every interval that the admin specifies, let's say for this example, 15-minute of RPO or 15-minute schedule, Portworx will automatically copy not just my application data, but all the application components, including these service objects, pods, PVCs, everything gets copied from my primary cluster and it's ready to go on the tertiary cluster. So in case of a disaster event, if my primary cluster goes offline, I can recover all my applications on my tertiary cluster with an RPO of 15 minutes and an RTO, or recovery time objective, of a couple of minutes. And then as that third layer of protection, right? If you just want to protect yourself from, say, data corruption or accidental deletions, you want a backup somewhere that's offloaded to a third site. Maybe you are all on-prem, but you still want a copy of your data in an AWS S3 bucket that's super secure for backup purposes. Portworx Backup allows you to protect not just your containers, which is what it was built for, but also the virtual machines that are running on OpenShift Virtualization or the KubeVirt project. And you can take those VMs, those pods, those Kubernetes objects, and your application data and store the entire application snapshot into an S3, AWS S3, FlashBlade S3, blob store on Azure, or a Google Cloud Object Storage bucket, and use that as that backup repository. So this becomes my backup tier. So with Portworx, organizations can build a synchronous disaster recovery solution, an asynchronous disaster recovery solution, and a data protection solution that allows me to protect or back up my applications. And these applications can be completely container-based or completely virtual machine-based that are running on OpenShift Virtualization or KubeVirt, or it can be a mix of both as well. That's it for this demo. Thank you for watching.